If you want to see more videos related to electrical and electronics engineering, then check the playlist section of this YouTube channel. Also, if you want to see more subjects like signals and system, power electronics, digital electronics, and electrical machines, and all the subjects related to electrical and electronics engineering, then also check the playlist section of this YouTube channel. Also, if you want to visit our website, then check the link in the description below. There you will find quizzes, notes, and simulators and much more. So now in this video we will see series and parallel. So in this video we will see how we can connect resistors in series and how we can connect the resistors in parallel. So here we can see this is the symbol for resistor. Now here if we add one more resistor like this, let's say this is R1 and this is R2, and let's add one more, let's say this is R3. So these connections are known as series connections, or we can write series circuit, we can say. So these are the resistors connected in series. So here the total resistance or RT will be equal to R1 plus R2 plus R3. And remember that when we have to increase the resistance, that time we add or we connect resistors in series. And also remember that the current through them will be same. That is, this current I will be same in resistor R1. Let's say this current is I1 and this current is I2 and this current is I3. So here I is equal to I1 is equal to I2 is equal to I3. The current through them will be same. Suppose this is 1 ampere. So this current will also 1 ampere, and this current, the current through R3 will also be 1 ampere, and likewise. Now let's see parallel. Now if we connect resistors like this, so these are called parallel connection or parallel circuit or resistors connected in parallel. So here we can see this is the parallel connection. Let's say this is R1, this is R2, and this is R3. Now here the total resistance will be RT. It will be like this: 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we have to calculate like this to get the value of RT, that is total resistance. Now here when we have to decrease the resistance, that time we connect more resistances. That means if we add one more resistor and if we add one more resistor, then the resistance, the equivalent resistance will be decrease. Now here these resistors are connected in parallel, and let's say this current is current I, and now this current is, let's say, I1, and this current is I2, and this current is I3. Now here these current may be same or may be different because they are connected in parallel. So these currents are not depend on the values of R1, R2 and R3, but the voltage across them will remain same. Let's say this voltage is, let's say this is plus minus and this is V. Now let's say voltage across this resistor is V1. Let's write in different color like this. So let's say this is V1, this is V2, and the voltage across this resistor R3 is V3. Now here V is equal to V1 is equal to V2 is equal to V3. So in parallel the voltage across them will be same, and in series the current through them will be same. But here in parallel, the current may be same or may be different. It depends on the values of resistor. And here also similarly, let's say this voltage is V1, this voltage is V2 and this voltage is V3. So here also the voltage is different or it may be same, depend on the values of resistors. So this is about resistors in series and resistors in parallel. Don't forget to like, share and subscribe to this channel. Also check out the other videos in the playlist section of this YouTube channel. And thanks for watching.